Hi, and welcome to this section of the Advanced Calculus 2 Tutor. And in this section, we're going to continue developing our skills with trying to understand when series converge and when they do not. And we're going to talk about the comparison test, the so-called comparison test of series convergence. So in the last section, the main thing that we introduced was the integral test, which is basically you can take the integral of the equivalent function that would look like the terms in a series, and if that integral converges, then the series also converges, okay? And we know how to take integrals, so that's sort of a pretty bulletproof way to figure out if a series converges or not. Unfortunately, sometimes the integrals are going to be hard to find by hand. You know, there's lots of integrals that you can't ever find by hand. You have to use a computer to find them, and so it's not very helpful if you can't calculate the integral. It's not very helpful to figure out if the series converges or not, because maybe you can't integrate the thing at all. Okay, there's plenty of integrals you can't do. So in this section, it's called a comparison test, and that is because what we're going to do is we have the series that we want to look at and study and figure out if it converges. That one's called a sub n. Okay, and what we'll do is we'll look at another series. We'll make one up. It'll usually be related to the original series we're given. But what we'll do is we'll look at a related series, and we will see if that series converges or not, and we'll look at the behavior of that series, and under certain conditions, by comparing the series we're interested in, that we don't know anything about, to a series that we do know something about and how its behavior is, under certain conditions, we can figure out if the original series that we care about converges or not. There's some very specific things that have to be true, but if you can show that those are true, the comparison test is pretty easy if you can do that, and it's pretty powerful and pretty simple. So let's just jump into it. Okay, the comparison test. Okay, the comparison test. What is it? What are we going to do? We're going to say the following. We're going to say, suppose that the two series a sub n. This is the series that we care about. This is the series given to you in the problem to look at, okay? And Bn, this is the series that we're going to use to compare it to, okay? Have positive terms. So far as all it's saying is, suppose we have two series, the series that we're given and some other related series that I haven't told you anything about how to find, but let's just say that these two things have positive terms. What we're going to end up doing is comparing them, and we're going to learn something about our original series by studying a related series. That's what it's telling you, okay? So, part A, okay? If, and here's where the rubber meets the road, if the series B sub n, the one that we make up to sort of study, okay, to see how it behaves. If Bn is convergent, and, this is a very important and, the terms a sub n is less than or equal to B sub n, we'll talk about this in a second, for all n, I'm going to underline that, for all n, then the series that we cared about, a sub n, converges. Okay, a picture is worth 1,000 words, and so I'm going to do that right here, okay? Let's say this is a little XY graph here, and this is n, and this is, you know, the term in the series that we care about, okay? Let's say I'm trying to study, a sub n, which is a series, right? And let's say that the, you know, n is equal to 1, 2, 3, 4, 5, 6, 7, whatever. You know